Hello students, welcome to IFAS. So in today's lecture, we are going to talk about the short concept about forces on a dielectric. So let's talk about this force on a dielectric. Force on a dielectric. Suppose you have a capacitor plate over here. You have a capacitor plate over here. And there is another capacitor plate over here. So it's basically a parallel plate capacitor. This is basically a parallel plate capacitor. Now, if this is a parallel plate capacitor, what I did, I have placed a dielectric, but yes, of course, I'm trying to move it outside of the material. And suppose I have made X distance outside of the material. So this is my dielectric. It's my dielectric slab. And X distance is outside of the dielectric. This distance is actually your X. This is actually your L, the length of the parallel plate capacitor. This length is actually your L, and this one is basically your D. This one is basically your D. So tell me, I can consider this configuration of parallel plates and this dielectric as two capacitors which are connected in parallel. So one capacitor I can say epsilon naught dielectric constant 1 into X into A. A is basically the breadth divided by D plus for this epsilon naught. This is basically my K, epsilon naught K into L minus X into A divided by D. You see epsilon naught A by D is common, and you will get X plus KL minus KX. If I take common this epsilon naught A by D, this one can be written as KL negative of K minus 1 into X. You can write it like this. So this is my capacitance basically. This is the capacitance of this configuration. Now we know for sure that basically when I'm talking about this force upon a dielectric, that is forced by me upon a dielectric, so that force is negative of the force by the field. So we can simply just call it as, if you wish me to say, it will be equals to half C V square. That is my W. It is equals to half CV square, which is my W. Now, if I know that this one is half CV square, which is my W, that is the energy of this capacitor when it has a constant potential V. Suppose I have connected it with a battery, and that battery is maintaining a constant potential, that is E. Then what can you say? That I can mention that this half CV square will become equals to half or V square by 2 into epsilon naught A by D KL minus K minus 1 into X. This is my W. What is my force? Force equals to, what can I say? Force can be said to be equal to negative of or W dx, I can say. If I say force equals to dW dx, you can differentiate this function with respect to X, and what you will get, the first term is 0 and second term is, it is V square by 2 epsilon naught into A by D, epsilon naught into A divided by D. And then I can say simply K minus 1. Of course, there is a negative sign. Negative of V square by 2 epsilon naught into A by D, and there is a K minus 1. What can I say? Sir, basically this force is negative, which implies the fact that the force is actually in the direction of reducing the value of x. Force किस डायरेक्शन में काम करे? सर फोर्स इस डायरेक्शन में काम करे ताकि x का वैल्यू कम हो जाए. इस मींस x का वैल्यू कम कब होगा? जब डायलेक्ट्रिक अंदर की तरफ आएगा. Therefore, the dielectric will experience a force that will try to force, the dielectric will experience a force, an attractive force, into the capacitor. Therefore, whatever force the dielectric will feel is an attractive force, and the capacitor is actually trying to pull the dielectric back into the capacitor. And of course, the capacitor is trying to pull the dielectric back into the capacitor. It's trying to pull the dielectric back into the capacitor. It's trying to pull the dielectric back into the capacitor. Okay, then, fine. Thank you very much for today. I think this is sufficient. On the next class, we will discuss again. So this was a short concept which says force on a dielectric. Thank you very much. Happy learning.